Welcome to Aristomath. In this video, we shall consider arithmetical progression or linear sequence. By the end of the lesson, the learner will be able to find the general term and nth term of a linear sequence. Now let's look at the definition of arithmetical progression or linear sequence. Arithmetical progression or linear sequence is a sequence in which the consecutive terms increase or decrease by adding or subtracting a constant. The constant is what is known as the common difference. For example, we have 2, 4, 6, 8. Now, we have a sequence on the board, and this sequence is up to infinity. It means the last term is unknown. This sequence has a common difference of 2. The common difference is found by subtracting the first term from the second term, or by subtracting the second term from the third term. That is 4 minus 2, which gives us 2, or 6 minus 4, which gives us 2. Therefore, 2 becomes our common difference of this sequence. Now let's look at how to find the general term or nth term of a linear sequence. The general term or the nth term of a linear sequence is found by using the general formula of a linear sequence, which is un equal to a plus bracket open n minus 1 bracket close d. And we also have L equal to a plus bracket open n minus 1 bracket close d, where n equal to the number of term or terms, and a equal to the first term of the sequence. I also have d which is the common difference. That is the difference between the second term and the first term, or the difference between the third term and the second term. The common difference is found by subtracting the first term from the second term, or by subtracting the second term from the third term of the sequence. We also have L in the second formula, which means the last term. This formula is used when the last term is given. Let's take some examples. Example 1 says you should find the 10th term of a linear sequence 5, 10, 15, 20. There's 3 dots over here. The 3 dots means it's up to infinity, which means the last term is unknown. So to find the 10th term of this sequence, we have to put down our general formula for finding the general term of a linear sequence. That is, so we have our general formula to be un equal to a plus bracket open n minus 1 bracket close d, where n in the formula refers the number of term or terms given. So the number of terms given is 10. So we have our n equal to 10. And we also have a, we said a refers to the first term of the sequence. So the first term of the sequence is 5. So we have our a equal to 5. And we also have our d, the d which is the common difference. The common difference is found by subtracting the first term from the second term, or by subtracting the second term from the third term, which is u2 minus u1, or u3 minus u2. So we know our u2 to be 10, that is the second term, which is 10, minus the first term, which is 5, or our u3, which is 15, the third term, minus the second term, which is 10. So we have 10 minus 5 gives us 5, or 15 minus 10 also gives us 5. Therefore, our d is equal to 5. Now, since we know our values for n, a, and d, we just substitute them into the general formula to find our 10th term. Now, let's substitute our n, a, and d into the formula. So we have un, which our n is 10. So 10 equal to our a, which is 5. So we have 5 here plus bracket open n, which is 10 minus 1 bracket close our d, which is 5. Now we solve the resulting equation. So we have u10 equal to 5 plus 10 minus 1 gives us 9 times 5. So we have u10 equal to 5 plus 9 times 5 gives us 45. So we have 45 here. We have u10 equal to 5 plus 45 gives us 50. Therefore, our 10th term is 50. Now let's take our second example. Our second example says you find the nth term of a linear sequence 1, 3, 5, 7 up to infinity. So to find the nth term of a linear sequence, we use the general formula, which is un equal to a plus bracket open n minus 1 bracket close d, where our n equals the number of terms. So the number of terms is n. So we have n equal to n. A equal to the first term of the sequence, which is 1. Then our d, which is the common difference, which is u2 minus u1. So we know our u2 to be 3 and our u1 to be 1. So 3 minus 1 gives us 2. Therefore, our d is equal to 2. Now, since we know our values for a and d, we substitute them into the formula to find a term for the n. So we have our un equal to a. Our a is 1 plus bracket open n is n. So we have n minus 1 bracket open d. Our d, which is 2. Now we solve the resulting equation. We have a bracket over here. So we have to expand to remove the bracket. To expand to remove the bracket, the number outside the bracket will multiply each of the numbers inside the bracket. So we have un equal to 1 plus 2 times n gives us 2n. 2 times minus 1 gives us minus 2. So here we group like 10. We have 1 and minus 2 over here. So we have un equal to 1 minus 2 plus 2n, which will give us un equal to 1 minus 2 gives us minus 1 plus 2n. Therefore, this becomes our nth term. Our third example says we should find the number of terms of an AP 3, 7, 11 up to 31. Now, we have to find the number of terms of this sequence. We know the last term of this sequence. Since we know the last term of this sequence, we use the general formula, which is L equal to A plus bracket open n minus 1 bracket close d, where L refers to the last term. L equal to the last term. So the last term of the sequence is 31. So we have our L equal to 31. And our A, which is the first term of the sequence, which is 3. Then we have n over here. N, which we don't know, that's the number of terms. So n equal to n. Let's replace n by n. Then the d, which is the common difference, which is u2 minus u1, where our u2 is 7 minus our u1, which is 3. So 7 minus 3 gives us 4. Therefore, our d is 4. Now, since we know our values for L, A, and D, we substitute them into the formula to find our number of terms. Now, our L equal to 31 equal to A. A is 3 plus bracket open n, which we don't know. So you have n minus 1 bracket close D, which is 4. Now you solve the resulting equation. So you have 31 equal to 3 plus, here we expand to remove the bracket. So n times 4 gives us 4n. Minus 1 times 4 gives us minus 4. So here we group our like term. So we have 31. We subtract 3 from this since it's positive. So we have minus 3. And also add 4 to this one since it is negative. So which will be plus 4 equal to 4n. 31 minus 3 plus 4 gives us 32 equal to 4n. Here we are finding for n, so we divide both sides by 4. So which will be 32 divided by 4 equal to 4n divided by 4. 4 cancels 4. 32 divided by 4 gives us 8, which is equal to n. Therefore, n equal to 8. Thank you for watching. Please try these questions on your own and leave your answers at the comment section. Please subscribe for more videos.